Okay, hello everybody. Today we're going to continue our discussion in Chapter 5, Section 1. This is the third video in a series of 4 that I'm going to record. And today I'm going to show you some applications of exponential functions. And this is kind of where we're going to be transitioning into your student loan information, which is going to be utilizing our knowledge of exponential growth to do some calculating about loans. And so it says one of the most familiar examples of exponential growth is an investment earning continuously compounded interest. We know that the formula for interest compounded n times per year is, and then they proceed to give you a formula. Now, I want to back up a little bit because I think they kind of make an assumption in this paragraph that I think it's important to talk about. And that is what it means to have interest compounded. Now, what it means to have compounded interest is how often the bank or whatever institution that you have your money invested in gives you the interest for your investment. So the way it works is if you have a sum of money and you put it into, let's say, a savings account, the bank either once a month or once a quarter or maybe even once a year will give you interest. And it's basically your reward for having money in that account. Now, the bank doesn't just take that money and leave it in the account. They take that money and then they lend it to someone else who might need money to buy a car or buy a house or something like that. And they make money because they charge that person interest using your money. And so, how does the bank compensate you for the use of your money? They pay you interest. Right now, interest rates are low, but you never know when they're going to change. And we'll talk more about interest rates here in a little bit. But what I want you to understand is that it varies how often they pay you your interest on your money. They could pay you as often as every day. They could pay you weekly, they could pay you monthly, they could pay you quarterly, which means every 3 months, or they could pay you once a year. It really just depends on the institution where you have your money in. So this formula allows us to adjust for how often interest is compounded. And the variable that we use for that is this variable n. And you can see it occurs 2 places in the formula. So n stands for the number of compounds per year. Now, what are the other variables? Well, let's go over them from left to right. So this right here, this A is our account balance. It's going to be how much money we will have after the interest is paid. The P right there is going to be the principal amount that is deposited. So let's say you have $5,000 and you put that into your account. That is going to be the P, 5,000. R is the interest rate that the bank is paying you. And that can vary. It varies basically on what type of thing that you're investing in. Stocks are going to get better interest rates than savings accounts, but stocks are a risk. Whereas savings account, there's really no risk to you losing your money in a savings account. The thing to keep in mind about R, when you put the number in for R, it must be in decimal form. It cannot be in percent. So if they're giving you 5% interest, you cannot put a 5 in for R. You have to put 0.05 in for R. That's one of the most common mistakes that I see students make with this formula. Now, we've already talked about what n is. N is the number of compounds per year. And then T is the number of years that your money is invested for. So be very careful that T has to be in years. So as an example, if you only invest your money for 6 months, you would have to put 0.5 in for T because 6 months is half of a year, which is 0.5. So once again, A is your account balance. That's how much you have when you have your interest included. P is the principal amount that is invested. R is the interest rate. It must be in decimal form. N is the number of compounds per year, which is how many times the interest is put back into your account. And then T is the amount of time in years. So we're going to use this formula to solve a problem. Now, this goes through and shows you how that formula was derived, and I'm not too worried about you knowing how that works. So the other formula that I need to show you before we get into trying some problems is for continuous interest. Now, there is such a thing where the interest is automatically rolled in. It's not put in once a month. It's automatically, as it's earned, it's put back into the account. And that is called continuously compounding. Now, if you think about the idea of compound interest, you're making interest on your interest because they take the money you earn and they put it back into your account. And then the next time they calculate interest, you have more money in there. So you're going to earn more interest. So it would be beneficial to have continuously compounding interest because you will be earning interest on your interest the fastest. Now, unfortunately, most banking institutions don't do continuously compounding interest, though. But there is a different formula for that. So if you recall in the previous video, I said about E, the actual number E, which is 2.71828818. That number is in right here in the formula. So I know it looks like a variable, but it's not. The A still stands for your account balance. The P stands for still the principal amount that is invested. The E, you would use your E button on your calculator. The R is your interest rate in decimal form, and then the T is time in years. So they're all pretty much the same except for the E. You can see that that formula is easier because it doesn't have to worry about how often the interest is being compounded because it's being put in continuously. So depending on the problem, you will use one of those two formulas. It really depends on how often the interest is being compounded. So let's take a look here. So we have an example where it says you invest $12,000 at an annual interest rate of 3%. They want you to find the balance after 5 years when the interest is compounded, and then they give you three different scenarios. They want you to find the balance when it's compounded quarterly, and then monthly, and then continuously. So these first two are going to utilize that first formula that we had, and then the continuously is going to be the last one, the A part. So I'm actually going to start with the continuously one because I think it's the easiest. And so our formula is A equals P E to the RT. And so all we need to do is go ahead and substitute in the values that we have for each one. We are looking for our account balance, so the A doesn't get anything substituted in for it. The principal amount that is being invested in this case is 12,000. So that goes in for P. As I said, the E is an E. It's not a variable that you substitute in for. The interest rate is 3%, but 3% converted to a decimal form, 3% is 3.0. When you convert to a decimal form, you have to move the decimal place over two places. And what we end up with is 3% is equivalent to 0.03. So that is what we're going to be putting in for R, 0.03. And then the last number that we need to substitute in is the number of time. In this case, it said we are going to invest for 5 years. So I'm going to put 5 in for T. Now, the next step to this is getting your calculator out. It is definitely easier on a graphing calculator than a scientific, but you can do this on a scientific calculator. And go ahead and typing this in. Now, you got to be a little careful. This formula is not as hard as the other one to type in, which I'll show you here in a second. But we're going to start with 12,000. We're going to multiply by E. Remember, E to the is the natural log, second natural log key. And then we need to put 0.03 times 5. Once we have that all typed in, we can go ahead and hit enter, and you can see that after 5 years, investing at 3%, we will have increased from 12,000 to a new account balance of $13,942.01. And there's your amount. My iPad's being super sluggish. I apologize. There's the 01. Okay, so $13,942.01. Okay, so the next thing that I'm going to show you is how to use the first formula that we had to solve for quarterly and monthly interest. And so the formula that we have is A equals P 1 plus r over n to the n times t. Now, when it says quarterly, that means that's over the year. So every quarter in a year is every 3 months because 12 divided by 4 is 3. So the account balance stays A, our principal stays 12,000. Then it's 1 plus, our interest rate is still 0.03. The number of compounds per year, if it's quarterly, it's 4. So we're going to write 4 right there. And then once again for n, it's 4, and then times the amount of time, which is 5. And so that would be what we would fill in. So most of the variables are the same. Really, the only different one from the continuous is that we have the number of compounds per year. And quarterly means 4. So typing this into your calculator is a bit trickier because there's a lot going on in this problem. I'm going to move myself over here so you can still see my calculator. So I'm going to go ahead and I'm going to type 12,000. I'm going to put a set of parentheses, but we have to be pretty liberal in our use of parentheses, and you'll see why here in a second. So I'm going to write 1 plus, and then I'm going to put another set of parentheses, and I'm going to write 0.03 divided by 4, close that parentheses, close the other set of parentheses, and then I'm going to write to the, and then I'm going to put in 4 times 5. Now, as I told you guys before, if you're using a TI-83 and it only shows the caret and it doesn't put you up high like it does on mine, you will need to have a set of parentheses around the 4 times 5 as well. Now, typing that in, and go ahead and hit enter, and you can see that I would have $13,934.21. All right. Now, that is slightly less than the $13,942.01 that we got from the compounding continuously. And it should be because it means the interest is not being rolled in as quickly, so we're not earning interest on our interest quite as quickly. So that was for quarterly. Now we will solve for monthly. So quarterly is only 4 times a year. Monthly is a little bit more than that. Monthly, if they're paying you interest monthly, you're going to get your interest rolled in 12 times a year. So you're going to be a little bit more often. So once again, the setup is the same. It's A equals 12,000. 1 plus 0.03 is your interest rate, but now it's monthly. So N turns into 12. So that's really the only thing that changes in that entire formula is that the number of compounds is now 12. Now, how can you do this? And I want to show you an easier way. We've already spent the time to type in this equation right here. Rather than retyping the whole thing and having to put that 4 into a 12, you can hit second and then enter. And what it does is it brings up the entire thing that you just typed in, the last thing. Then you can go back in and change that 4 to 12. Now, since it's a single digit, I'm going to have to type 1 and then second insert 2. And you can see it scooched everything over, and I was able to put that 12 in there. And then I'm going to go up here and do the same thing with that 4. I'm going to type 1, second insert 2, and now everything is changed to a 12. I can hit enter, and I get my amount for this, which is the account balance is $13,939.40. So looking at all three, the continuously is the first. This would be the best. If you could get that, you're going to get the most amount of money. In a close second is the monthly, and then last, the least amount is going to be quarterly. Now, that doesn't seem like it's a lot of money because it's really not. I mean, it's a difference of what? We have 13,942 versus 13,934. So less than $8. But when you're talking about tens of thousands of dollars or hundreds of thousands of dollars in the case of when you're trying to save money to retire, how often the interest is compounded can make a pretty big difference. And these are just the typed out answers to what I just showed you. So that's what I have for you today. I hope that made sense on how to use those formulas and which to use when. and I've got a couple of example problems I would like you to try on your own. As always, if you have any questions, feel free to email me. Have a great day.